Welcome to IronCAST, the official IronCAD podcast about all things CAD. IronCAD is a leading provider of innovative 3D design solutions trusted by design engineers across industries like machinery, equipment, and modular manufacturing to help streamline their workflows. I'm Rufarum Shashi, a product marketing engineer at IronCAD.
And I'm Akai Williams, a product application engineer at IronCAD. And today we have some fantastic topics to talk about. The biggest thing is about the power of thinking in 3D. And we're actually joined by a special guest, Cameron Schriner, a software engineer at IronCAD, who actually plays a really, really big part in a lot of the development. And so I hope as we go through this episode today that we really can pick his brain and receive a lot of his knowledge. He's been with IronCAD a very, very long time.
Happy to be here.
Yes, good to have you on, Cameron. Good to have you on. But it's a quick note. We have IronCAD 2025 launched in December 2024, but coming up soon, we actually have the SP1 update. So be on the lookout. We have a lot of cool and interesting features in there. I think piping is included in this as well.
That sounds exciting. Like we said, Cameron's with us. I'm so excited to have you here, Cam. You have been very helpful, very instrumental to Makai and I's guidance since we've joined the team. And so it's great to have you on IronCAST, which is our IronCAD baby. So please tell us a little bit about yourself. How did you get into software engineering?
So that's actually kind of funny. By degree, I'm actually a mechanical engineer. But when I was finishing up schooling at Georgia Tech, I was working for a small company that was dealing with extracurricular, like curricular designs for high school and middle school. And I was using IronCAD at that job at Tech. And then so that kind of led me into meeting everyone here. But when I started thinking about wanting to work here, they needed a developer because we were still pretty small. So I didn't want to lose the opportunity, so I learned C++ and applied to be a developer, even though I'm a mechanical engineer.
Oh, wow.
So you learned how to code so that you could join IronCAD.
Yeah, just so I could work here.
That's very interesting. So our topic for today is thinking in 3D. And since you're a software engineer now, and you've had the experience of being a mechanical engineer, do you find that you think in 2D, 3D, code, some combination? Like how does your brain work?
So I would say that I've almost always thought in 3D, but that's what kind of made CAD hard for me because all CAD and all drafting and like all of my schooling, everything is 2D based. Having to look at drafting tables, like even throughout high school, like any kind of design you did in the workshop or anything when I was building with Dad, everything started in 2D, but I've always been a 3D thinker. I like to imagine the object in my hand. And that's the way I've kind of always been. Even when I'm designing something, I pretend like I'm picking it up to see it first.
Wow, yeah. As an engineer myself, it's very critical to be able to think in 3D because when I think of a design, I don't just think of we talked about last time, just thinking of like a 2D square box and then making it a cube and then making it a rectangle. You just think of the rectangle. You think of this is what I could turn it into. It's like when you have a piece of wood or a piece of steel.
And that's because you're already thinking about like its application, not about how to make it.
Yeah.
Like even when you're initially designing a piece, you start by thinking how you're going to use it, not how do I build it?
Right.
Yeah. So in a sense, like when you're thinking, you almost have to reverse engineer it so that you break it down into its components, and then you can like start doing that design based on what the functionality is going to be like.
Exactly. Because like in order to understand the initial shape, you have to know what it's going to be used for. So if I'm designing a special kind of pen, the obvious first step is, well, it has to be small enough to fit into a hand.
Yeah.
So it's like I've always thought from function down to form first.
Wow, that's
Nice.
perfect.
And so when did you begin to differentiate between 2D and 3D thinking? I know that you mentioned, your beginning is in mechanical engineering and in 3D design, but when did you kind of get to that point where you have to break things down and like reverse engineer them and put them back into 2D?
I think it was when I actually started building more complicated anythings. So like in high school, in my technology class or in my shop class, like when I joined the robotics team, it wasn't me just bandsawing out a little figurine for my mom for Christmas or something like that. I had to actually design a gearbox, or I had to design a CO2 card in order to win the in-class competition. And
Mm.
when you had to start getting very technical, like when I had weight limits and when I had design specifications that I couldn't break, that's when I needed to then break down my design into 2 dimensions so I could start individually designing components instead of thinking about the overall function.
So is that the point where you become more, when you start to focus on the details, when you have to start like breaking things down?
Yes, after I have that initial design, when now I have to make sure that it is able to be built or manufactured, is when I then have to break it down into the 2D side.
Ah, that's fair enough, right? You got to give it to the people to make it, right?
Exactly.
Nice. So what are some of the challenges engineers face when transitioning from 2D into 3D thinking, or I guess vice versa? Because like you mentioned, sometimes you start in the third dimension and then you start breaking things down. So like,
Well,
what are some challenges?
I think the main challenge is because most people, or at least in my experience, most mechanical engineers will think in 3D first and then transition to 2D just because modern CAD starts in 2D. And in my opinion, the hardest transition to go from thinking in 2D to thinking in 3D is the flexibility of 3D.
Mm.
Because in 3D, you can look and you can imagine a shape by looking at it in any angle. But when you're working on something in 2D, you can have things like hidden lines and forced perspectives that can kind of skew what you may think your final shape will look at. So I think the hardest part is the inflexibility of 2D.
That's pretty
Yeah.
cool.
That's one of the like great things about IronCAD is that you're not forced to think in that like breaking it down into that two-dimensional space.
Exactly.
And then you have to, do it into 3D. You kind of just start it as you see it, as you imagine it,
Even
which is really
Even
cool.
one thing in IronCAD I can even say too is because you do everything in IronCAD in 3D. But one of the features IronCAD has is the drawing feature, the bulk drawing feature. And so even as an engineer, you don't even have to necessarily go and break it up into 2D because IronCAD already does it for you. And so
Mm.
I don't know for you, Cameron, you've been developing here for a while. So I guess you've worked on a little bit of ICD as well. So I guess how is it, being able to even develop that part of IronCAD to be able to, for the engineer to solely be able to focus on the 3D, but even being able to just have a click a button and boom. I'm not sure if you own that part, but I guess maybe you can elaborate a little bit on it.
I actually do. I work a lot in the 2D side. When I first started out, I was working more on the 3D side with Smart Assembly, but then I started transitioning into the 2D. And that's exactly what it was, is that we're trying to make the drafting side as automatic as possible,
Mm.
because it's the nitty gritty. It's the final piece of engineering just to get to manufacturing. That's all it is. So we want engineers to be able to focus on just getting their design out and being done, and the manufacturing processes to be simplified. Like you said, one click button, boom, your drawings are done, all your viewing angles are done, your bomb's done. It can go off and you can move on to your next project. That's
Mm.
kind of my favorite part. And honestly, how I fell in love with IronCAD in school before I even considered getting a job here.
So it's kind of like you're working to do the translation portion for the like computer to be able to understand. So in the same way that you have to break down language into code, which I mean, I guess code is arguably language, but
No, but that's exactly what we do, is
yeah.
as we break it down from language, human speak, into computer speak. So you were right on the money.
Yeah, and so, like, similarly, when you're doing 3D into manufacturing, you have to kind of do that same translation of breaking it down from 3D into 2D.
Exactly, because all of the manufacturing processing machines, like the cutting angles and things, they only know their specific task and their specific code, and that's what drafting is for engineers, is being able to transition from the physical design into the manufacturing blueprint that the manufacturing processes can understand for turning your product into reality.
Which is super cool. I mean, coming a little bit of a sidetrack, but, like, for myself, I come from, like, a film background, and codecs kind of do a similar things where you are essentially translating data into a digestible format for the computer or for the software that you're using, whatever it is, and then it after you use that codec, then now it's something that the computer can understand.
Yep.
So in a sense, it's similarly just like a lot of translating from the way that you think it, the way that you see it, the way that you hear it into something that is a smaller form.
Exactly. So like on the development side, your coding language then gets compiled into machine language. And then in engineering, your 3D model is your speech, your language, your code, and that gets compiled into 2D or just like your codices. And then that's what allows the manufacturing process to get it. So it's actually all very similar processes. But the best part about us starting in the 3D is that you don't have to worry about what I'll call the grunt work translation to get to manufacturing. You can just design. It's just fast and flexible.
That's awesome.
Yeah. And so like in terms of improving the ability to think in 3D, because I know for a lot of engineers, once they start, once their mind is kind of broken down into the 2D of things, it can kind of be hard to just let your mind wander into the 3D in the 3D space. So how do you suggest like developing or improving the ability to think in 3D, whether that's like specific exercises, tools, softwares that you have come across, that kind of thing?
Sure. So actually the way I did it is that like traditional drafting is when you're designing a part, you have to think about the cross section and the shape of the cross section. So if you're going to have a cube with a hole in it, you have to think about the boundary lines and where that hole is going to be positioned in space. But you don't have to be limited by constraints in that way. And the way that I transitioned to start thinking about 3D is breaking down objects into their most basic geometric components. So like when you look at a water bottle or a coffee mug, its core shape is just a cylinder. It's a cylinder with just some little curves and edges cut into the sides.
Yeah.
And that's kind of what helped me to start thinking about how do I build this thing in 3D space? Because I didn't have to think about the angle of all the curves and the ridges in a water bottle that I would then have to spin into the bottle, which you would do normally for 2D to 3D style drafting.
Yeah.
Whereas now a water bottle is just a cylinder. So I just have to make a single cylinder with a tiny cylinder on top for the smaller neck. And then I have to make a slightly bigger cylinder on top for the lid. And then I just add defining features to that. And it's so much simpler to start and to just get going than instead having to think about measuring the radii of each curve to figure out this exact 2D shape that I can spin into a 3D shape. It's just so much easier breaking it down to its simple geometry.
It seems like it's like eliminating some like the fine details in the beginning stage. You can just kind of put some in there.
Yeah.
Exactly. And go back and redefine everything. Like you don't have to constrain all the like you said, the fine points or the radii or getting this angle, this measurement. You can just kind of go in and toss everything in there.
Yep. So the first thing I ever made in IronCAD when I was learning, when I was self-teaching in school, because I was using IronCAD instead of other CAD software in school, because like I said, I think in the 3D, and this was the only one that was available at the time. And the first thing I made was a push pin, like just a standard push pin that you put in a corkboard. And I got a little overwhelmed, like pulling out protractors and trying to figure out the angles of, it has the top push part, the small neck, the bottom of the pin, and then the pin itself, when it just kind of clicked when it's cylinder to loft to cylinder for the point and a cone on the end. And it's like, once you get the basic shape, the details are easy to add later.
So it's kind of like basically breaking down a shape into smaller shapes that essentially, once again, are more digestible in your own mind. And then you can do that translation into the computer.
Yep. Get the basics down first and the details can come later.
Wow.
Yeah. So do you think that schools focus enough on teaching 3D thinking, or is that mostly something that you learn on the job, or things that, children are supposed to learn when they're playing with toys? Like how do you, is there enough focus on 3D thinking?
When I was in school, definitely not. Everything was 2D, but that's because we didn't have the same level of access to 3D application or a 3D example of what you are learning. Like these days with 3D printers, you can make a physical example of something, of pretty much anything. Whereas when I was in school, everything was on pencil and paper or on chalkboard or whiteboard. So we always thought in 2D and just had to imagine the 3D side. There really was no 3D thinking. All of that was after school. So like my robotics club, or when I would go home and design how to make a bicycle motorized by slapping a lawnmower engine on the back, which was a stupid idea. I don't know why Dad let me do that. That thing was so dangerous. But everything in 3D was outside of a learning environment, because in the learning environment, it was all pencil and paper.
Wow.
Yeah, and that's why I brought up like children learning what like during play, because I know for a lot of younger people, that's how they learn to experience the world in 3D is by playing in it. And so we have things like Legos, we have like you mentioned 3D printers, even things like climbing and playing with balls and breaking things apart and whatnot.
Beyond the real world.
Yeah.
Yeah.
Yeah, like all of that stuff is like real world.
And school was just school. School was books, papers, projectors, and boards.
Yeah.
All flat 2D surfaces.
Do you think,
Which
or I guess, yeah,
Go ahead.
and add on to that, do you think schools should probably implement more of these like 3D practices?
Yeah, absolutely. And they're starting to, which is the coolest thing, because now imagination is now possible to put into your hand. And I know that sounds super cheesy, but it's like now kids can think, oh, I want a duck with a top hat, and now they can just print it, and now that is on their desk, and they can be super excited. And it's the little things like that is what gets kids so motivated, is yes, taking that 2D education environment and expanding it into what we consider real outside of school.
Yeah.
That'd be really, really cool to see. And even with IronCAD, because I mean, you're taking some time in it, and you were even using it back when you were in school, as well. So even, from my experience, a lot of the engineering side of it, in high school or in even college, a lot of it is in 2D. But even for myself, I think in 3D. And so maybe even with IronCAD, like you were saying, kind of having that more creative way of having the kids while they're younger be able to think in 3D rather than just giving them the pen and paper.
Well, think it's more natural.
Yeah.
Like we are 3D entities. And it would make sense that if you're designing something that is eventually going to be built, why wouldn't you design it in the same dimension that it's going to become?
Right. Wow. That's a good way of thinking. It's kind of hard to think in 2D when you're in the 3D world.
Yeah, once you've like if you've had the opportunity to engage in like play and things that improve your 3D visualization, like once you've done something in 3D, it's hard to go to do that translation into 2D. But for a lot of people, like Cameron said, like you start learning about technical stuff in 2D. And so that's the way that your brain is kind of like shaped.
Well, yeah, kind of wired.
Yeah, that's kind of how you're wired. And speaking of, I guess this is IronCAD related, but also just in general, in your experience, can you give an example where thinking in 3D led to a breakthrough in your work?
Ooh, thinking in 3D led to a breakthrough. I think it was when 3D printing first started coming out, and realizing that like what exactly I'm seeing on the computer can almost instantly become real.
Yeah.
Like that's kind of when the possibilities kind of really exploded for me, is just because now you weren't limited to certain manufacturing processes. Your prototype could be done instantly. In a couple hours, you could have a physical prototype in your hand, and you can just get back to designing. Now that you've looked at it in real life and you're done, I think that was the biggest point, was being able to compare the actual reality and be able to relate it directly into your CAD. So there wasn't really like a single point. It just worked. The second I found IronCAD, I replaced all my other CAD with it. And like I said, this was way before I even considered working here, because I was still in school. And that was just because it just makes sense.
Yeah.
So I think, as weird as this sounds, my my biggest breakthrough was just finding IronCAD.
Yeah.
It wasn't like a specific project or a specific moment. It was just this software lets me design in the space that I'm eventually going to have my product in.
Yeah. Finding IronCAD really does like create breakthroughs as it pertains to like how you do modeling, how you do 3D modeling. It's just such an easy software to use, and it's such an intuitive software to use. I mean, every single episode is going to basically sound like a commercial, but it really is that great. Like, it really is that easy to be like, okay, I have this shape, as you were saying before. How do I break it down into smaller shapes for the computer to understand? And the computer is already, or the software is already smart enough to be like, well, you don't need to do all of this extra steps of getting it into 2D, like,
Or constraining it or anything.
or constraining it.
We're
Yeah.
history based, but not history bound, and that's the best part. If halfway through your design you can just be like, oh crap, I need to move this piece somewhere else. You don't have to roll back everything you've already done. You just use the tribal, move it, and reform everything for you. It's just
Yeah.
it's like just physically moving the features in real life, which is
Yeah.
what makes it so easy. And it's kind of like finding IronCAD is kind of like the first time you go from using a single screen on your computer to now a 2-monitor system.
Yes.
Once you go to that 2-monitor system, you can never go back, which is why I've never gone to the 3-monitor system, because I know I'll never be able to go back. But like finding IronCAD is the CAD version of discovering life with a second monitor.
Wow.
Yeah. I think actually doing a third monitor would make it somehow more complicated.
You think that, but I have friends who can't go back now that they've had
Oh,
3.
really?
And so every setup they own now is 3 monitors, and IronCAD's the same way
Yeah.
when it comes to CAD.
It's always the upgrade.
Once you start using it, you can't imagine how you were ever designing constrained in 2D before.
Wow. That's a good way to think of it. A lot of engineers have 2 monitors, so they can probably put that in perspective.
Yeah.
Okay, that's awesome.
And so what role does 3D modeling play in bridging the gap between engineers, designers, and clients? I know that, it's kind of more intuitive for humans to think in 3D, but how does that 3D modeling, bridge that gap?
Well, you kind of said it. It is the bridge, because clients, most of the time, clients aren't going to be thinking about the technical processes that go into designing the products they need.
Right.
They're thinking about what the designer starts with. They're thinking about the end function. And so when you have a 3D modeler, or when you have an engineer that's designing your product, if they're designing it in 3D, that means they can more closely work directly with the clients, because the clients can now understand on a fundamental level what they're working on. They can see their product coming together. They're like, oh no, now that I see that edge needs to be rounded a little bit more, or when you're doing the FEA, this piece is a little too brittle, and the clients can be more connected with their product and with their design process, instead of it just being, here's my idea, having to wait for the engineers to come back later with all these draftings and all these 2Ds, and the client not being able to put it all together in their head. They can actually see their physical models as they're being built and be able to understand it, because the client's in a 3D space.
Oh.
Yeah.
So it's a bit more intuitive.
We kind of talked about this. Yeah, it's way more intuitive. And we kind of talked about this last, I think it was maybe, I guess, 2 episodes ago, where with Carrie, where we were saying how having IronCAD in the room with, like, you can have IronCAD in the room with people of varying experiences, and almost everybody in that room is able to make changes. Everybody in that room is able to understand what they're seeing because it's already in 3D. And you can have like salespeople be able to do the adjustments, and they don't have to do that, that go back to the middleman, go back to the engineer to do, the changes for them. So I think that that's like a really cool, way to think of it, is that 3D modeling is the gap. I mean, is the bridge in the gap.
But like specifically designing in 3D
Right.
part of 3D modeling, yeah, it is the bridge, because the client is in 3D space.
Right. Wow.
Nice.
That's awesome.
And lastly, we kind of touched on this a bit, but in general, how does working with IronCAD change the way you think about design in general?
So for me, it it allows me to think about all of the smaller interim steps more often. So like to me now, prototyping is so much easier because I can iterate more and I can iterate faster, which helps me get to my main goals. So I'm not afraid of spending too much time getting it perfect on the first try. Whereas if you're designing in 2D first, you have to be thinking about constraints and form and end goal function, when now being able to design in 3D without having to define everything first, it it makes the prototyping process just go so much faster, and it's so much easier to conceptualize
Yeah.
because I don't have to be thinking about the end goal during the middle steps because we're not bound by it.
That's so cool. That's so cool.
Yes.
Makai, do you have any last questions for Cam?
You know, I pick my brain.
While we have him here?
I think for Cameron, because he's been working in IronCAD for so long, like if I'm sure you've worked in like SolidWorks and like Revit and different kind of 3D modeling software throughout your time.
Yeah, that was all of my schooling. And my brother is a licensed SolidWorks user. So whenever I'm designing with him, he's using SolidWorks.
So I guess like comparing the two, I guess how when it comes to SolidWorks versus IronCAD, I guess how would you say the complexity of being able to design in each? Of course, one's 2D based and one's 3D based, so it may not be necessarily in the same eye level when it comes to design.
Like apples to
Right.
apples.
Yeah, of course. But that's why, like, this is why I naturally switched to IronCAD in school, was because I noticed that you can get the exact same complexity in modeling, but the steps to get there were so much easier to do and so much, honestly, just more fun because you can just play around with shapes in IronCAD. Like, and that's why it's like, SolidWorks is like the private school where you have to button up in your collar every day, and IronCAD is like is the public school where you get the exact same education, but you don't got to wear the suit every day.
Yeah. You can wear shorts and a Hawaiian t-shirt.
It's just more comfortable. It's more natural.
That's great. And I think even with IronCAD, if you were to see IronCAD more in school, I guess like wait, where would you want them to start? 'Cause I know some kids don't get into like 3D modeling until they get to college, when they get to have those programs, or even when it comes to like high
So
school.
one of my favorite parts about once I actually started to get working here is that I got to combine my old job at Georgia Tech with like this passion that I have for teaching kids STEM, because I'm also like a head state referee for FLL robotics, and you can start this, like, IronCAD is so easy, you can start in middle school. That's the best part about it. We can be as complicated as rebuilding a Boeing 777, but at the same time, a middle schooler can pick up our software and understand that if they put a block with a cylinder on top, they can print themselves the world's simplest microphone and have fun with it. And that's kind of like the absolute best part. We could start this in middle school and get kids used to designing their world because it's so intuitive.
Awesome.
Yeah.
They don't have to learn the mathematics of drafting.
That's amazing.
The part of the reason why I laughed a bit when you were talking about the microphone thing is because when I was talking about a couple episodes ago about how easy it is for someone to learn IronCAD, I gave the example of me designing a logo. In fact, the logo for IronCAST was designed in IronCAD, and it was very easy to do so. I mean, even for someone like me who doesn't have like a ton of experience in the designing aspect of IronCAD, but I have a pretty good eye for design in general.
That's because you can look at an object and understand the basic shape. Yeah, like most microphones, like modern microphones, are just rectangles with rounded edges.
Yeah.
And so, which is literally just a cylinder. So and that's kind of plays back to what we were talking about before, is that it's so easy to use because it's designing in the space that the product is going to be in.
Yeah.
Wow.
That's a beautiful way to
That's
put
great. That's a beautiful way to put it. IronCAD, from my time in using it's been a really, really big help, and it really, really bridged that gap between being able to think of my design and really be able to put it into reality. And so especially, with the 3D world, the 3D printers that are, they're being upgraded every single week, it feels like really, really being able to take your imagination and make that imagination a reality. IronCAD really has that fundamental part of it that really just it's any engineer going really.
From parties to particle physics.
Indeed.
Thank you so much, so much, Cameron, for being on with us today.
No problem. It was fun.
Listen, we're gonna have
Yeah,
you back
it'll be
again.
back, I feel.
In fact, you might be on the next episode when we're gonna be talking about Inventure, as we were talking about like learning, children learning in school how to think in 3D and all that stuff. Like that's gonna be you're gonna be welcomed.
I will
that
be
topic.
happy to come. Yes, please do. It was good to have you on today.
Thanks, you guys.
Of course.
Makai, do you have a tech tip for me
I
today?
actually do. Today, I do have a tech tip. So today's tech tip is actually talking about the property list viewer. In IronCAD, actually, instead of having to go into specific details, you can just simply click on your part. In the bottom right, shows a property list viewer. You can edit the mass. You can edit the naming. You can edit anything within the property of that specific part or assembly, and to just really upgrade your workflow, make it a lot quicker, a lot more efficient. So go check that out on the YouTube channel, on LinkedIn as well. You'll be able to see more in detail.
Nice. Thank you very much. And just a quick recap of this episode. We learned from Cameron a lot about thinking in the third dimension and how people go back and forth between learning from 3D, translating into 2D, and just really just being able to design in a more intuitive way. A shout out to all the listeners and contributors to this podcast, which at this point is really just IronCAD. But yeah, everybody, please do make sure that you go to IronCAD 2025 to the free trial page. Get yourself a free trial of IronCAD 2025. You will not be disappointed. Subscribe to the podcast for more insights and tips, and follow us on social media accounts for any updates and community highlights. Thank you once again for tuning in, and please join us next episode where we will be exploring Inventure, which is a super cool program that Cameron is involved in. If you want to give a quick little blurb about Inventure.
I love Inventure. So I helped start it at Georgia Tech when I was working there. And essentially think of the science fair, except with inventions instead of science.
Yeah.
That'll be fun.
Very exciting stuff. I've judged a couple of projects so far, and they're very exciting. You guys do not want to miss next episode. But with that, thank you all very much for listening, and we'll see you next episode.
Episode has been IronCAST.
This has been IronCast, an official IronCAD podcast.
Featuring Makai, Rue, special guest Cameron.
All right, everybody, take care.